Hello guys, welcome to Deep Codes, and in this video we will discuss LeetCode question 2654 that says minimum number of operations to make an array element equal to 1. So guys, this question is a part of LeetCode weekly contest 342 and this is the last question of the contest. So here in this question you are given a zero index array nums consisting of positive integers and you have to do following operations on the array any number of times. Now what this operation says that you have to select an index I such that I is between 0 to n minus 1, that is between the range, and you can replace either of nums of I or nums of I plus 1 with their GCD value. Okay, that means if you select any index I, then you have to calculate GCD of index I and the number at index I plus 1, and the answer, let's say answer is x. So with any of the number, either nums of I or I plus 1 can be replaced with the x, right? You can replace any of this number with x, not both, only one, but any of them, right? So you can replace the number with the GCD value of these two. And we need to return the minimum number of operations to make all the elements of the nums equal to 1. So all the elements, let's say in this nums you are given these elements 2, 6, 3, 4. Then at the end, after performing n number of operations, you have to convert all these elements into ones, right? As you can see here. So that's how we need to do the operations, right? This by replacing the numbers, and at the end we want ones at all the places. Okay, now if you take a look at the first example, so here 2634 is a nums array. So at first what we are doing is we are finding the GCD of 3 and 4. The GCD is 1, right? So we get something like this 2614. Then we using this one, right? See, GCD of any number, let's say any number num with 1 is always 1. GCD of any number with 1 is always 1. So once you get 1 inside your array, then it's easy to convert all the other numbers to 1. So that's why then we took GCD of 6 and 1, it answer is 1, GCD of 2 and 1 is 1, GCD of 1 and 4 is 1, and that's how we converted all the other elements to 1. So total number of steps here we took is 4. So that's why we written 4 as our answer. And now here if you try to do GCD of any of the numbers, then it is not possible, right? See, GCD of 2 and 10 is 2, so you convert 10 to 2. GCD of 6 and 14 is what? It is again 2. So let's say you replace 2 here, 14 here. GCD of 2 and 14 is 2. So at the end you will get all 2. And GCD of 2 and 2 is nothing but 2. So yeah, you won't be able to convert all the elements of this nums array to 1. Means you won't be able to convert any one also, one of the element to 1 also, right here. So that's why we written -1 as our answer when it is impossible to convert elements of a nums array to 1. Okay, so I hope the question is now clear that what we have to do for any given elements of nums, then we have to replace some of the in nums of y to the GCD value of the adjacent element, and then at the end we need to make all the array elements to 1, right? So first of all, let us discuss that what is GCD. GCD is nothing but greatest common divisor. Greatest common divisor, and in other words you can say it is a greatest factor between two nums n1 and n2. It is the greatest factor between two nums n1 and n2. Okay, so let's say you have to find GCD of, let's say, 8 and 64. The answer is 8. Okay, because the greatest factor between 8 and 64 is 8 itself. If you are finding GCD between, so the GCD of 14 and 63 is nothing but 7. So yeah, 7 is the greatest factor that is common between 14 and 63. So yeah guys, that is now clear that GCD is nothing but a greatest factor between two nums n1 and n2, and you can also tell it like greatest common divisor, or the greatest number that can divide both the numbers. Okay, that is the alternate way of a definition of GCD. Now what is our goal? So for any given input like this, our goal is nothing but to convert all the numbers to ones like this. So this is our goal set. Okay, keep in mind this is our goal set. Now for an example, if we already have 1 in our input, then won't that be easy? So yeah, if you have already 1 like this is here, it is 1, and here also we have 1, then in one operation what we can do is convert this 3 to 1, right? GCD of 3 and 1 is 1, so convert this 3 to 1. So you will get 1, 1, 2, 6, 1. In the second operation, you can convert this 2 to 1, right? By taking GCD with this one. GCD of 1 and 2 is 1, 1, 1, 6, 1. And in operation 3, what you can do, you can convert 6, this 6 to 1. Okay, 1 1 1 1 1. Okay, see this, if you have already 1 in the input, then it is very much easy to get the answer, because GCD of any number, let's say x with 1 is always 1. GCD of any number with 1 is always 1. So yeah, if you have 1 already in the input, what is our answer? Our answer would be n, that is the size of the array. This is size of array minus count of 1. Okay, so if you have here 2 ones, then and the size is 5, so 5 minus 2 3. So these 3 operation will make other digits to 1. So this is our answer. This is simple, that if you have, let's say, x ones and there are n elements in the array, so our answer would be nothing but n minus x, right? The remaining elements can be converted to ones in this number of steps. So these are the number of operation required to convert all the elements to 1. So yeah, if you have some ones in the input array, then this is our answer. Okay, clear till here? Now moving ahead. So when can all the numbers in an array be converted to 1? So if you have given some input like this that doesn't contain 1, so when this input array can be converted to 1, so it can be converted, means when you will get these ones, like this type of answer, at a point, at some stage, when you can get at least 1 1. So at some point, by finding out GCD between two numbers and performing the operation, and if at any some point you get 1 in the array, then after that it is very much easy, right? After that it is very much easy. So let's say in x1 step you can get first one, you get first one, then what is our answer? X1 plus remaining elements. Okay, x1 plus remaining elements, and this remaining elements is nothing but n minus 1. So because x1 is the operation, number of operation required to get first one, this is for first one. So how many remaining elements are there? N minus 1. So our answer is x1. So for this our answer is x1 plus n minus 1, number of steps total. So this is our answer. X1 is the number of steps to get first one, and for the remaining it is n minus 1 steps. Okay, got it? Clear? So our problem reduces to find minimum number of operation to make at least one in the array, to get at least one in the array. So this is our final problem, right? After that it is very much easy to convert all the other numbers to 1. Got it? So for any given input like this 3, 6, 8, 12, 16. So let's solve this question first. Okay, so if you take the GCD of 3 and 6, the answer is 3. So let me replace 6 with 3. And now if you take GCD of 3 and 8, you get answer what? You get answer 1. So let me replace 8 with 1. Okay, so in two operation I got first one. Okay, so what is our answer? Our answer is nothing but 2 plus n minus 1, that is 4. So our answer is 6. It is simple, right? After this you take GCD of 1 and 12, the answer is 1, replace 12 with 1. You take GCD of 1 and 16, answer is 1, replace 16 is 1. 1 and 3, answer is 1, replace 3 with 1, and here you will get 1. So taking GCD with 3 and 1, the answer is 1, and replace this 3 to 1 also. So in the next 4 steps you can convert all these 4 digits to 1. It is simple. So this is how in 2 steps for this input we got the first one, and after that our solution is very much simple. So now we need to find how many this answer, the minimum number of operation to get at least one in the array. So for that what we will do is we will run a 2 for loop. So inside this for loop from I to n, okay, this is the outer for loop, and the inner for loop will run from I plus 1 to n. Okay, and we will find all the GCD of all the numbers, right? GCD of all the numbers. So what we are doing is for 3, 6, 8, 12, 16. See, first what we do, we find GCD of 3 and 6. Let's say this is x1. Okay, then what we are finding? We are finding GCD of x1 and 8. Let's say this is x2. Okay, so this is how, by taking the first answer, we find the GCD. So this is nothing but GCD of 3, 6 and 8, and at this point for this input you will get 1. So in 2 operation GCD of 3 and 6, and then its answer with the 8, you will get the first one in the output. So yeah, GCD of 3 and 6 is 3, and then GCD of 3 is 3. With this 8, you will get this first one, correct? So yeah, this is how we will stop if we get the 1 as our answer, right? So this is how we will approach the way, by taking the 2 for loop and checking for all possible sub-arrays. So we will check for all possible sub-arrays in the range L to R, right? We will try to find all possible sub-arrays, right? So that's why we took 2 for loops. This is nothing but to check for all possible sub-arrays. And yeah, if at any place we get GCD answer as 1, then we would stop, right? Afterwards it is very much simple. If you get x1, then afterwards it is very much simple. Got it? So yeah, now let's move on to the coding part. And I hope you guys have understood that all these things, like what is GCD, what is our goal, what if we have a 1 already in the input, what are the numbers in the array, when can all the numbers in the array become 1, if you get the 1 1, then all can become 1 easily, and how to find minimum number of operation. So that is nothing but by checking all the possible sub-arrays. We have to check this, then only we can find how in what minimum operation we can get at least 1 1. So yeah, now moving on to the coding part. Here what I did is, first I took the count of 1 in the given nums array. So if a count of 1 is greater than 0, that means we have some ones in the array, and I return what? Size of the nums minus the count of 1. Okay, this is our answer. Now after that I check for all possible sub-array, right? So starting from from the first index, I took the current sub-array GCD this variable, and then I performed the GCD with this variable and the current nums of j, right? And if at any point this current sub-array GCD, so if you find this sub-array GCD equal to 1, then at that point what I did, I updated the minimum sub-array, that is the length of minimum sub-array, or you can say minimum, this is nothing but minimum operation to get first one. This is nothing but minimum operation to get first one. So whenever you get the first one, I updated this value minimum sub-array to j minus 1, right? J minus 1, because this many operation we have performed, right? Let's say I equal to 0. So for this example only, 3 6 8 12 16, 3 6 8 12 16, here I is 0. So what first we did is we perform GCD of 3 and 6. This is some x1, then we perform x1 comma 8. So for that, what is at this point, what is the j? J is nothing but 2, right? And at that point we got GCD as 1. So what is the operation we did now? How many operation we did? We did nothing but j minus I, that is 2 minus 0, that is 2 operation, right? To get the first one for this input. So yeah, that's how I calculated the minimum number of operation, that is nothing but the difference between the index j and the index I, right? And yeah, after that simply break, because after you get the first one, it is very much simple. So that's why if the minimum sub-array is not equal to int max, that means we have some found at least one in the by taking the GCD, and then the answer is this minimum sub-array plus the size of the nums minus 1, right? This is the remaining elements, and this is minimum operation to get the first one. Okay, clear? So guys, that's how we concluded to our answer. And now talking about the time and space complexity. The time complexity for this approach is big of n square, as we are running the 2 for loops, and the space complexity is big of 1, as we are not storing anything. So yeah guys, that's all for this video. If you guys have any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.